Hello students, I am going to deliver a lecture on triple integrals in 5th unit of matrices and calculus. For today's lecture, we will see how to evaluate the volume of given surface using triple integral. For now, we will see the triple integration in Cartesian coordinates. A triple integral of a function defined over a region R is denoted by triple integral over R f of x by z dx dy dz. But this can also be written in another form, triple integral over R f of x by z dv, where dv equal to dx dy dz. For now, next we will see volume of solids. Triple integral over R dx dy dz represents the volume of the region R. Therefore, the volume V is equal to triple integral over V dx dy dz or triple integral over V dz dy dx. Or simply we can write triple integral over V dv, where dv equal to either dx dy dz or dz dy dx. In triple integral, all the three variables will vary on the given surface. So first we have to find the limit of these three variables. Of the three variables, one variable will have a constant limit and second variable will be in terms of first variables and third variables will be in terms of first two variables. So option is yours. You can take any variable to have a constant limit and other two will be in terms of the first two variables. Now we will see some problems for finding the volume of the surface using triple integrals. Our first problem is find the volume bounded by the cylinder x square plus y square equal to 4 and the planes y plus z equal to 4 and z equal to 0. We know the formula for volume. Volume V is equal to triple integral over V dx dy dz or triple integral over V dz dy dx. So use any one of the formula here. So here I am taking V is equal to triple integral over V dz dy dx. For now you want to write the limit for z, y and also x. So first for y z limit. That one is obtained from the plane equation y plus z equal to 4 and z equal to 0. So y plus z equal to 4 implies that z equal to 4 minus y. Therefore, the value of z varies from 0 to 4 minus y. Next, we have to find the limit for y. So that one is obtained from the curve equation x square plus y square equal to 4. For solving these equations, we get y is equal to plus or minus root of 4 minus x square. For therefore, y varies from minus root of 4 minus x square to plus root of 4 minus x square. Finally, we have to get the limit for x. That one is obtained from again the curve equation x square plus y square equal to 4. For now, we want to put y is equal to 0 in that curve equations. We will get x equal to plus or minus 2. So x varies from minus 2 to plus 2. Now replace all the values in the above formula. So we get v is equal to triple integral minus 2 to 2 minus root of 4 minus x square to plus root of 4 minus x square and 0 to 4 minus y dz dy dx. Our first integration is with respect to z, so we have to integrate with respect to z of the limit 0 to 4 minus y. For now, here we have the term integral dz. So integral dz is z over the limit 0 to 4 minus y dy dx. Now apply the limits, upper limit 4 minus y minus of lower limit 0 into dy dx. 4 minus y minus 0, that is 4 minus y. But next you have to integrate with respect to y. So when you are integrating with respect to y, treat the other variable x as a constant term. So integral minus 2 to 2 dx, that one is a constant term. So remaining one is integral 4 minus y into dy. So integral 4 into dy is 4y minus integral y dy is y square by 2 over the limit minus root of 4 minus x square to plus root of 4 minus x square. For next, you have to apply the limit for y equal to root of 4 minus x square. So 4 into root of 4 minus x square minus of y square. There's a root of 4 minus x square the whole square. So root term and square term will be cancelled. So we'll get 4 minus x square by 2. For this is for upper limit. Minus of lower limit, put y is equal to minus root of 4 minus x square. So first term is minus 4 into root of 4 minus x square minus 4 in minus x square by 2 into dx. Now simplifying these expressions, we will get minus 1 by 2 4 minus x square and plus 1 by 2 4 minus x square. These two terms will be cancelled. So we will get 8 into root of 4 minus x square dx. Here 8 is a constant term, so it can be taken out. So 8 into integral minus 2 to 2 root of 4 minus x square dx. For now, the integrand part is root of 4 minus x square. This one is an even function. So by the property of definite integral, integral minus a to a f of x dx equal to 2 times of integral 0 to a f of x dx. If suppose the function is even term, then we can write like this. Here the function root of 4 minus x squared is an even function, so you can write like this. 2 into integral 0 to 2 root of 4 minus x square dx. I already have on 8, so 16 into integral 0 to 2 root of 4 minus x square dx. For now, we want to integrate root of 4 minus x square dx. Now this is in the form of integral root of a square minus x square dx. We know the formula for integral root of a square minus x square dx. And this one is equal to x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a over the limit. Now here the value of a square is 4, so you replace the value a is equal to 2 in this formula, and then we will get x by 2 root of 4 minus x square plus 4 by 2 sine inverse of x by 2 over the limit 0 to 2. Now apply the limit, put x equal to 2 in this expression, so we will get 2 by 2 root of 4 minus 4 plus 4 by 2 sine inverse of 1 minus of lower limit is x equal to 0. When you replace x equal to 0, the first part becomes 0 plus 2 into sine inverse of 0. For now, we know the value of sine 0. Sine 0 is 0 and sine pi by 2 is 1. For sine 0 is 0, so from this we can get the value of sine inverse of 0. Sine inverse of 0 is 0 and sine inverse of 1 is pi by 2. Replacing these two values, we will get 2 into pi by 2. This implies that 16 pi cubic unit, but this is the volume of the given surface. For next, we will see a second problem. Find the volume of the sphere x square plus y square plus z square equal to a square without transformations. We know the formula for volume. Volume V is equal to triple integral over V dx dy dz or triple integral over V dz dy dx. Here we want to get the volume of a sphere. We know that the surface, suppose the surface is symmetrical about all the three axes, then we can take the surface in the first octant multiply by 8 is the total volume of the surface. And this remember that this is possible only when the surface is symmetric. Here the surface is sphere. This one is symmetrical about all the three axes, so we can multiply by 8. Therefore, the volume of the sphere equal to 8 into volume of the sphere in the first octant. For the V is equal to 8 into triple integral over V dz dy dx. Next, we want to get the limit for z, y and x. Now, here the surface lies in first octant. In first octant, x value, y value, z values are 0 and also positive. For now, for z limit, solving the equations x square plus y square plus z square equal to a square. So from this we get the value of z equal to plus or minus root of a square minus x square minus y square. For therefore z equal to root of a square minus x square minus y square, because the value of z is positive in first octant. For next, you have to find out the limit for y. So for this, you have to put z equal to 0 in that equation. X square plus y square plus z square equal to a square. So solving these equations, we get y is equal to plus or minus root of a square minus x square. And y and the value of y is positive in first octant. For therefore, we consider only a positive value. So y is equal to root of a square minus x square. For next, you have to find out x limit. For finding x limit, replace the term z equal to 0, y equal to 0 in x square plus y square plus z square equal to a square. So from this, we get the value of x equal to plus or minus a. And also we know that in first octant, x value is positive. For therefore, x takes 0, a only. For therefore, the value of z varies from 0 to root of a square minus x square minus y square, and y varies from 0 to root of a square minus x square, and x varies from 0 to a. Now replacing all the limit values in the above integral. For therefore, v is equal to 8 into triple integral 0 to a, 0 to root of a square minus x square, and 0 to root of a square minus x square minus y square dz dy dx, which is equal to 8 into integral 0 to a, integral 0 to root of a square minus x square. Now the integral dz is z. So z over the limit 0 to root of a square minus x square minus y square dy dx. Now replace the limit z equal to root of a square minus x square minus y square. This is the upper limit minus of lower limit 0 into dy dx. For now, next we want to integrate with respect to y. When you are integrating with respect to y, treat the variable x as a constant term. Here a square is a constant, x square is a constant. So a square minus x square is a constant term. So these two are the constant terms. Now you want to integrate with respect to y only. Now this is in the form of integral root of a k square minus y square dy. And the value is y by 2 root of k square minus y square plus k square by 2 sin inverse of y by k, where k square equal to a square minus x square. Now replacing the value of k here, k in this formula, for therefore y by 2 root of a square minus x square minus y square plus k square is a square minus x square, so we can replace it. So a square minus x square by 2 sin inverse of y by root of a square minus x square over the limit 0 to root of a square minus x square dx. Next we have to apply the limit y is equal to root of a square minus x square. For the first part becomes root of a square minus x square by 2 into root of a square minus x square minus of y square value is a square minus x square plus a square minus x square by 2 sin inverse of y value is root of a square minus x square divided by root of a square minus x square. This is the upper part minus of lower limit. So replace the term y is equal to 0 in the first one. The first one, when you replace y is equal to 0, the first part becomes 0 plus a square minus x square by 2 sin inverse of 0 into dx. Now in this integration, here we have the term in the root term, a root of a square minus x square minus of a square minus x square, and these two terms will be cancelled. So the first part becomes 0. So we'll get a square minus x square by 2 sin inverse of 1 minus of a square minus x square by 2 sin inverse of 0. And we know the value of sin 0. Sin 0 is 0. So from this we get sin inverse of 0 is 0. And sin pi by 2 is 1. So from this sin inverse of 1 equal to pi by 2. So replacing these two values in this integrand part. So we get 8 into integral 0 to a square minus x square by 2 pi by 2 dx. For now, pi by 4 is a constant term, so it can be taken out. So already have 8. So these two are cancelled. So we get 2 pi integral 0 to a square minus x square dx. For now, we want to integrate with respect to x. So integral a square dx. The a square is a constant term. So integral dx is x minus of integral x square dx is x cube by 3 over the limit 0 to a. For now replace the term x by a. So a cube minus a cube by 3 minus of lower limit. When you replace x equal to 0, the lower part becomes 0. So simplifying these expressions, a cube minus a cube by 3 will get 2a cube by 3 into 2 pi. Solving this we get to 4 by 3 pi a cube cubic units. This is the volume of the sphere. Thank you.